Hey guys, in this video we're going to start the next chapter of the course, and we're going to be talking about atoms, molecules, and ions, and a lot more stuff as well. And so this time I'm going to be breaking the chapter up into shorter videos, hopefully. So we will focus this first video on early ideas in atomic theory. And so we are going to look at what's known as Dalton's atomic theory, and we will go through the postulates of that theory and then use those to explain different laws that we see in chemistry. So we'll encounter a pair of laws: the law of definite proportions and the law of multiple proportions. Dalton was one of the early chemists who proposed the idea that matter could be explained in terms of atoms. He introduced several ideas or postulates as part of his theory, and he supposed that matter is composed of extremely small, indivisible particles called atoms, and that these atoms retain their identity during chemical reactions. He also proposed that elements consist of only one type of atom, and that there are different atoms, and that different atoms have different properties. For example, different atoms would have different mass. Compounds are substances that, according to Dalton, that consist of atoms from two or more elements, and that the atoms combine chemically in simple fixed proportions. For example, two atoms of one type of element to one atom of another type, and so on, all sorts of combinations. He also proposed that chemical reactions involve the rearrangement of atoms in different ways to give new chemical combinations and thus new compounds. Okay, so these are the 5 postulates of Dalton's theory. You don't need to memorize them verbatim, although you do want to be familiar with them. Here are just some graphical examples of what we're talking about. So, for example, the copper in pennies. Copper is an element, and copper would consist of atoms of copper. And all copper atoms are identical, and they all have the same properties. For example, all copper atoms have the same mass, at least according to Dalton's theory. And compounds like this copper oxide, this dark brown powder that you see here, is a combination of both copper and oxygen. Okay, and so copper and oxygen elements combine in a particular ratio to form this copper-2 oxide, the compound. And when this reaction between copper and oxygen gas occurs, the atoms within the copper oxide are the same atoms that you had in the reactants. That is, the copper atoms don't change their identity when you undergo a reaction. The oxygen atoms retain their identity. They're just combined in different ways to give you a new compound, the copper-2 oxide in this case. What can you deduce from Dalton's theory? Well, one thing you can deduce is the law of conservation of mass, which we've already encountered. Right? If atoms have a particular mass and they are not destroyed in a chemical reaction, then the mass of the reactants and the products will remain constant. Right? And so Dalton's theory is consistent with what was known previously as the law of conservation of mass. Dalton's law also is consistent with what's known as the law of definite proportions. Compounds consist of particular atoms in certain ratios. Therefore, if you take a compound and you decompose it, you're always going to get the same proportions of elements, no matter where that compound came from. So all sources of a given pure compound always decompose to give the same proportion of elements. That's known as the law of definite proportions. Dalton's law also predicts the law of multiple proportions. That is, you can combine elements in different proportions to make different compounds. And one example would be carbon monoxide, where you have one equivalent of carbon and one equivalent of oxygen, versus carbon dioxide, where you would have one equivalent of carbon and two equivalents of oxygen at the atomic scale. And so that's the idea of the law of multiple proportions. Just a few words on the law of definite proportions, also called the law of constant composition. All samples of a pure compound that contain the same elements in the same proportion by mass. So, for example, pure water is always the same. It doesn't matter where it comes from. In a second example here, if you have a sample of sodium chloride, common table salt, if it's a 1 gram sample of sodium chloride, and you decompose that sodium chloride, you will always get 0.4 grams of sodium metal and 0.6 grams of chlorine. And it's the same no matter where that sodium chloride comes from, as long as it's pure sodium chloride. And you can do things like scale that up. So if 1 gram of sodium chloride produces 0.4 grams and 0.6 grams of sodium and chlorine respectively, how many grams of sodium and chlorine would you get out of 10 grams of sodium chloride? Well, you can simply multiply these numbers by 10. So 10 grams of sodium chloride would give you 4 grams of sodium and 6 grams of chlorine. Okay, so these ideas here, they illustrate the law of definite proportions. On this slide, I'm illustrating the law of multiple proportions. Here we've got two different compounds, this green powder that you see here and this reddish brown powder that you see here. Both compounds contain copper and chlorine. However, they contain different proportions of copper and chlorine. Okay? And so depending on the relative amounts of copper and chlorine, you will get these two different compounds. Okay, so this illustrates the idea of multiple proportions. That is, you can make distinct compounds from the same elements, but if you mix them together in different proportions, you will get compounds that have different properties. In this example here, we are illustrating the law of multiple proportions. So we have a compound A, which is a clear, colorless gas. It's stated that it has 4.27 grams of copper and 5.69 grams of oxygen. We have another compound that has a different proportion of carbon and oxygen. We're being asked, do these data, are they consistent with the law of definite proportions, the law of multiple proportions, or neither? We would say that they are representative of the law of multiple proportions. That is, you have one compound that has a ratio of carbon to oxygen of 4.27 grams to 5.69 grams, whereas this compound B has a different ratio. And those are different, distinct compounds. We can go ahead and skip this example problem. I'm going to go ahead and stop this video here, and we will pick up with the next section in the next video.